All right. So we were to rewrite this is operator. So there's our string of operators, plus minus times divide. We're going to call the index of method on that, passing it whatever was passed in. If whatever was passed in is one of those guys, it will return something that's not a -1. Otherwise, it'll return a -1.
Makes sense. Oh, it should have been on that beforehand. I did something slightly similar. I just forgot to add in everything.
Okay, so we just simplified string to int. We simplified is operator. Let's see, removing white space. Didn't really do anything there. Okay. Well, so in any case, does that solution make sense? We create the string that has all the operators in it, call index of on it, passing it the thing we're trying to detect if it's an operator. As long as it returns something other than -1, it must be an operator. Right? Okay. Next magic trick. Char to int. This guy takes a character as a parameter, and it returns the integer version of that character. How can we write that in terms of index of? Look at all that crap, all those lines. So how can we write that in terms of index of?
If it's an integer.
Well, if it's a 0, it should return a what? A 0. If it's a 1, it should return a what? If it's a 3, it should return a what?
Thanks a lot.
Make sense? So if I'm looking at bucket 0, where is the first occurrence of 0 in that string? 0. Where's the first occurrence of 1 in that string? Where's the first occurrence of bucket of 7 in that string? 7. That make sense? So that became a lot easier, didn't it?
Yeah.
Oh, what about isval?
AEIOU dot of index C.
So return so as long as the character is one of those guys, he's a val. Is letter?
A, B, C, D, E, F, G, all the way to the end. And then capitalize it.
So there's my whole alphabet. So we're going to return this guy to an index of not equal to -1. So that's how we detect if something's a letter.
This is very discouraging.
We detect if it's a number. Turn that. Make sense? Okay. So I can get rid of all this crap. It's just taking up space. Valuable space. That 2 hours of work just gone.
Do stuff the hard way first.
All right. So let's create a method that returns a string, and it's called Substring. That takes a from index and a string, and it returns a substring from that string. So for example, if we pass it the string hello, and the from index was 2, it should return LLO. Everything from bucket 2 on. That make sense? So make sense what I'm asking for here? So if I passed in a 2 and I passed in hello, this guy should return LLO. Bucket 2, bucket 3, bucket 4. So bucket 2 all the way to the end of the string. How would I solve that problem? Let's create an answer. We're going to be building a new string, right? Whenever we build a string, the pattern tends to be start with a new string, set it equal to the empty string, right? I'm going to have to go through my string s for int I is equal to from index. I is less than s dot length I plus plus. Each time through, answer is equal to answer concatenated with s dot char at I. Return answer. Make sense? Class method or instance method?
Class.
How do you know?
Static.
Static. How do we call class methods?
Uh,
Using the name of the class in which the method was defined. This guy was defined inside of a class called hello. So I'm going to do system.out.println hello.substring, and I'll pass it to and the string hello, and this should give me LLO. That make sense? So that's one version of substring. But let's say we wanted a second version of substring. The second version of substring takes in the from index and a to index, and it returns the substring that starts with from index and goes up to all the way, but not including to index. Okay, so same code. Except instead of s.length, we're going to say to index. Here's my L. If I pass it a 2 and a 3, 2 and a 4, LL, 2 and a 5, LLO. Make sense? Now, go ahead.
Can you repeat that, please?
Which part?
How I got the LLO.
Well, I'm passing in the string hello, and I'm saying start with bucket 2 and go all the way up to, but not including bucket 5. So I have a second version of substring I just wrote. One that takes in a from index, a to index, and a string, and it returns the substring that starts with from index, goes all the way up to, but not including to index. So I have two methods here, one called substring and another one called substring. So two methods with the exact same name, but they take in a different number and or type of parameters. And that's called, we mentioned this last time, what that's called? Polymorphism.
We didn't go over that one.
Polymorphism is more than one method with the same name and a different number and or type of parameter. So fancy name that means something very easy. Okay. So we think we have a pretty good idea on how string manipulation works. And we have a new power tool. Index of. Did we write remove vowels last time?
No.
Oh, that was a nightmare. Static, string, remove vowels, takes a string as a parameter. So as an example, if I passed in HELLO as a string, this guy should return, not print, but return HLL. That is the original string with all the vowels removed from it, right? So this is pretty similar to, what was it, question number 1 from your homework?
Mhm.
Except number 1 from your homework had you printing out all the, maybe it was number 2, printing out the non-vowels, printing out the consonants. I think it was it. But it's also similar to number 1 from that, to print out all the vowels. But instead of printing them, what we're doing is we're building a brand new string with only the vowels removed. So we're keeping all non-vowels. So there's a distinct difference between printing things as we bump into them and building up a brand new string. Does that make sense? How would you solve this problem? When I say remove vowels, so again, we're talking about problem-solving patterns. When I say remove vowels, the first thing that should pop into your mind is not that I'm removing vowels.
We're just not printing them.
Well, we're not printing anything here.
True.
We're building a string. Okay? But I'm not removing vowels because I have, in order to create a new string, I have to build a brand new string. I'm not removing vowels. I'm keeping non-vowels. Does that make sense? Whenever I run into something that is a vowel, I'm going to ignore it. I'm only going to hold on to the things that are non-vowels. That's everything else. Does that make sense? Well, how do we detect if something's a vowel? Well, we don't have any more.
Well, you can do the index of the vowel string, but
Well,
say
we probably write a function again, right? Is val. It takes in a char as a parameter. And what would this guy look like?
you can do the index of the return have the string of the vowels. Index of equal to -1.
Not equal to -1. Should return true as long as this guy is one of these dudes.
Oh, okay, you want it that way. Gotcha.
Right?
Mhm.
So as long as the index of C, when calling it on the all the string containing all our vowels, upper and lower case, as long as that guy returns something that's not found, we have a vowel, and we should return true. So now we have a little widget, a little tool called isVal that allows us to detect vowels. But now I want to write a function called remove vowels. How would I write this? So we're building a new string, so we're going to give ourselves a string variable and have the empty string. What are we going to do? Loop through all the characters in our string. Which characters are we keeping? We're keeping things for which isVal returns false. So if hello.isVal s.char at I, if not that is, if that guy returns false, then the answer is equal to answer concatenated with s.char at I. Keep them.
I have a question.
Sure.
If we're going to deal with the S, okay, it's going to change the S too. It's going to remove
Nope.
the vowel.
No. Have we modified s at all here?
I mean, if I did S here, in a sense of like answer, like S equal S, like,
Well,
I mean,
if you change s to the empty string right now,
it's going to change the S.
inside here s is new. It's not changed permanently,
Okay.
but you just broke your code.
Yeah, exactly.
Okay.
If
Like, you want me to remove vowels? Look, the vowels are removed. So is everything else. I removed everything. But yeah, if you said S equal to it, yeah.
It's going to change.
Right. Make sense? What if we were writing a method called replace vals, and this guy took in a character called new char and a string, and what we were to do is to replace all vowels in S, all vowels in our string, with new char. So for example, if we called this guy passing it, let's do a question mark for our new char and the string hello, this guy would boil down to H question mark LL question mark. That's what the result should be. Make sense? How would we write that? Again, we're focusing on patterns.
Checkman's following.
Yeah, you know.
So we're going to need a new string because we're definitely building a string, right? So string, called answer, is equal to the empty string. A loop to go through all the characters. Each time through, we're going to ask, are you a val? So if hello dot is val s dot char at I, if the current character I'm looking at is a val, what do I do?
Press on S. Combination like question mark.
By new char.
New char.
So if I'm looking at a val, ignore the val, but instead keep. So answer is equal to answer concatenated with new char. So replace the val with whatever our new char is. Else, answer is equal to answer concatenated with s dot char at I. Keep the non-val. And then ultimately return answer. That make sense? So we call replace vals. Passing it a question mark and hello. We get the E and the O replaced with question marks. Let me check something here real quick. Make sure you have everything you need. Okay, any questions about that? All right, so we've been using our got a newfound comfort with building strings. We've been using index of, so we have a new power tool. We also now know how to convert numbers into ints, correct? Using index of, using parseInt, integer.parseInt. So now, let me show you a couple other things that would be fun. Trying to decide if I want to show you arrays now or not. No, let's show you something else. Okay, so what I'm going to do here is let's go back to our example where we had something that looked like this. String s is equal to 125 plus 13 minus 2 times 5. Something like that, right? So we had some sort of math formula looking thingy. Well, we wrote this thing to collect numbers and all this stuff. What if we could, typically these guys are each called tokens. Make sense? These are each called tokens. And we have something called the Stringtokenizer. Well, here, let me start it on a an easy example. So I'll pass it S2 here. So I have a string S2 that is a bunch of characters separated by commas. Okay? So I'm going to build my Stringtokenizer. Now notice it's screaming at me because it wants me to import something. So if I highlight over it, it's going to ask me if I want to import java.util Stringtokenizer. So I'll go ahead and do that. Puts it up here, so now I have access to it. Now, what the Stringtokenizer does is it does this. So we create our Stringtokenizer right here. Then, as long as ST has more tokens, so think of it giving us this container. And as long as there's still something in the container, we can pull one token at a time out. But when we pull it out of the container, it's gone. It's like you're passing out candy at a parade. Okay? So as long as we have more tokens, we're going to print out those tokens. So what we should see displayed to the screen is an A, then a B, then a C, then a D, then an E. That make sense? So there's my A, B, C, D, E. There's a second version of our Stringtokenizer constructor, this guy. We'll talk about constructors a lot more later. But there's a second version of this guy that takes a third parameter. That is a Boolean as to whether or not you want the actual delimiters, these commas, returned as tokens. So now when I print out has more tokens, it's giving me not only my A, my B, my C, my D, and my E, but also the commas in between them. So imagine if I were to pass this S. And for my tokens, notice that the tokens are in a string format. I passed it 4 separate tokens, plus, minus, times, divide. And then I ran this. Notice it gives me 125 the plus sign, the 13, the minus sign, the 2, the times, and the 5. That make sense? Isn't that doing most of the work that we need for our homework assignment?
For the one that we just finished?
Number 4?
Yes.
It's just split it up, didn't it? So if we were writing the answer to number 4 using a string tokenizer, how would we solve that problem? Each token is either going to be, as we look at these are our tokens, right? First of all, we wouldn't need to remove white space, would we?
Nope.
Each token is one of two things. It's either a number or it's an operator.
Right.
If it's a number, we want to call integer.parseInt on it. If it's an operator, we want to store it as our next operator. Correct?
Yep.
Okay.
So do some if statements in the while statement.
Well, let's actually throw this into a method now. So we'll say static int, what's it called, process expression.
Yes.
Took a string as a parameter. We'll go ahead and we'll bring our code that we had up there in here. So we'll create our string tokenizer on all of our operators, plus, minus, times, divide. We'll say, yes, give us the operators as well. So as long as we have more tokens, let's start walking through tokens. So we have our int running total. Okay, we can start off at -1, that's fine. And then we have our char, actually, let's call it a string cur-op, because we're going to be getting them as strings. Okay, now, we're interested in whether or not the current guy is an operator. How do we tell if something is an operator?
If it's a new token.
Well, everything would be tokens. The numbers would be tokens.
If it's like number digits.
What's an operator? Operator is plus, minus, times, divide.
Right.
So how will I write the code to determine if something is an operator?
The if statement.
What kind of if statement?
The if statement saying if current, well, the
It has
token,
more things.
if token is
Here's the
equal
token.
to,
This guy is the guy that's either a number or an operator. How do I ask if he is a operator?
if it's equal to
Index
plus.
of the string of operators.
Take the index of the string of operators? Okay. Well, so our code doesn't look funky. Shouldn't we go and write his operator? But have this guy take a string as a parameter rather than a char, because we know we're getting tokens as strings. And what's this guy going to do? He's going to return plus, minus, times, divide, dot, index of s, not equal to -1. So it'll return true if s is one of those dudes. Right? And false otherwise. So if hello dot is operator, passing it st dot next token, if that's true, if I'm looking at an operator, what do I want to do with it?
Doing the calculate between the first and last.
Calculate it, or, well, probably we're actually storing the operator,
Also,
right? We're always storing the operator. Where's the operator stored right now?
console.
Is it?
Net in total.
Here's my code right now.
Yeah.
Where's my operator being stored?
nowhere.
I'm not storing it.
You should.
So I need to store it. You want to put it in cur-op?
Yes.
Okay, how do I put it in cur-op?
For equals next equals next token. ST dot
I
next
think
token.
the
Oh. This guy?
Mhm.
Well, we got a problem.
within
Remember, I had the candy jar at the parade.
is taken out.
I already threw my token.
Yeah.
It's gone. Okay. I checked it. I took it out of the candy jar and said, is this a token? Yep. Just tossed it down the street.
So S token minus 1.
It's gone. I can't get it back.
True that. Okay. So
I have another string here.
I need to store my tokens. So I need to create a string maybe called cur token. And we'll say cur token is equal to st.next token. Then we'll work with cur token. So if cur token is an operator, then cur op will be equal to cur token. Right? And we're going to start cur op off at our question mark, similar to what we did before. Otherwise, we're looking at a number. Right? If we're looking at a number, one of two things is possible. It's either the first number, and how do we know it's the first number?
Nothing like the current.
We know it's the first number if our current operator is a question mark. Right? That's how we know it's the first number. How do I ask if cur op is a question mark? How do I ask that question?
Char. Looking for the 0.
What, bucket 0?
Yeah, equal.
Like that? Okay. I agree. Why didn't you say this?
I can do it if I have just one character.
Well,
yes, because it's string. So it's string. Yes,
what's the double equal sign here?
equal to.
Equal.
It's the equivalence operator for primitive types, for primitive type values. So we can't say, is the string cur op equivalent to the question mark? It's not a syntax error. What it's actually doing is it's saying, are these guys the same string? Not do they contain the same characters, but are they actually the same string? Same pointer, same memory address. Okay, so the punchline is if we need to compare strings to other strings for equality, a string has to provide us with a method for doing it. And the string class has such a method called the equals method.
Is equal.
Just called equals. So this is an instance method in the string class, which returns true if the calling string and the provided string contain the same characters. This is case sensitive. Make sense? So, and this is how it would be defined. inside the string class. So it's a class method or instance method?
That is a instance method.
How do you know?
No static.
No static. Okay. So if we're out here, we would say if curop dot equals the question mark. That's the correct way of asking that question. That make sense? So if curop dot equals question mark, what are we going to do with it? We're going to say that this is our first number. And if it's our first number, what do we want to do? We want to say running total is equal to integer dot parseInt
Next.
not curop, cur token. Go ahead and stick the number we found in there.
Change the question.
Otherwise, if it's not a question mark, that means I already have an operation. And this is not my first number. I need to do some math. Correct? So in order to do some math, I need to do math. And then ultimately, it doesn't matter what all went down in here. Ultimately, I'm going to say curop gets cur token. I will update my cur operator at the very end, after I've either just done my non-operation or do some math before I destroy curop. So now I need to do the math. What's my math? I need to process an operator. Static int perform operator. This guy will take in a string op, an int num1, and int num2. And what will it do? It'll say if op dot equals the plus sign, return num1 plus num2. Else if op dot equals the minus sign, because now we're comparing strings, num1 minus num2. Else if op dot equals multiplication, multiply them. Else it must be division, so do division. Make sense? So what will we do in here? We will call hello dot perform operator, passing it curop, passing it running total, and passing it integer dot parseInt cur token. Actually, hold on a second here. Yep. Nope, hold on. If it's an operator, do that. Else, we must be looking at a number. Okay, good. Cur token's a number. And what are we going to do with the result of that? We're going to say running total gets whatever the result of perform operator.
What did you do to parse int? Thank you.
That should be my number. And when all this is said and done, I should be able to return running total. I should not actually have like a leftover number like I had before, because I'm not building up my numbers. My numbers are all contained inside my tokens. That make sense? Mm-hmm.
About the current, after the second else, not the first.
This guy?
There's, yeah, current of equal count token. No, not like, yes, this line.
This guy?
This statement, yeah.
Yep.
That's for the next, like, we have the first line number, digits, and the count operation, and the second.
So it says if I'm looking at an operator, if my current token is an operator, set current op equal to that, right? Otherwise, actually, hold on. We're backwards here because of the tokens. If I'm looking at a token and curop, here we'll write this pretty concisely. Curop is equal to a question mark. If that's true, then we want to do this. No, I don't want to do that. That's just going to make it more confusing. All right. We'll do it that way. If I'm not looking at an operator and curop is equal to a question mark. So this says if I'm looking at a number and curop is currently a question mark, then I want to just get the number. Else, if I'm looking at an operator and I'll be explicit even though we don't need it, and curop is not equal to a question mark. So if I'm looking at an operator, if I'm not looking at an operator, so I'm looking at a number, but curop is not equal to a question mark, then I need to do some math. What's the math I'm going to do? I'm going to do that guy. Running total is equal to curop, running total, and whatever the integer version of cur token is. Else, I must be looking at an operator. So I'll just set curop equal to cur token. So since I have a list of tokens, I'm just dealing with it explicitly. I'm saying create my tokenizer. I have all my tokens, that's numbers and operators. Keep track of my running total. Keep track of my current operators, start off at a question mark. As long as I still have tokens left. So if we use this as our example, 124 plus 2 minus 8. Let's use that as our example. Okay, so my first token will be this guy. My second token will be the plus sign. Third token will be the 22, then the minus sign, then the 8. We don't have to worry about that because they're all in the tokens. You'll see.
Can you spell 9 a little bit?
Well, let me trace this. All right, so process expression, we're going to take in a string kind of like this. We're going to tokenize it, so I'm going to be left with 1, 2, 3, 4, 5 tokens. So this while loop will go through 5 times, right? We read in our first token. First token will be the 124. Then we ask the question, is that guy not an operator? It's true that 124 is not an operator. And is curop equal to a question mark? Yes. So what am I going to do? I'm going to set running total equal to the integer version of 124. All right, spin through, get the next guy. So next operator will be the plus sign. Is the plus sign not an operator? It is an operator. So that's false. False. So set curop equal to that guy. So we're going to set curop equal to the plus sign. Then we'll get our next token, the 2. Is the 2 not an operator? Is it true that 2 is not an operator? Yes, that's true. Is it true that curop is currently a question mark? Nope. So we fall to this. It's true that it's not an operator, and it's also true that curop is not equal to the question mark. So running total will be equal to our curop, which is, which we never, no, we're good. Our curop, which in this case should be the plus sign, our running total, whatever that currently is, and the integer version of cur token. So we'll do the math, storing the result back in running total. All right, then we read in the minus. So that's going to be false. That's going to be false. So curop equals the minus. Swing back up, get to the 8. That's going to be false. This is going to be true. So running total will be equal to minus sign on whatever the running total currently is and the 8. Now we're out of tokens, return running total. We didn't have to do that thing after the loop like we did before because it's not like we had built up one final number. We got all of our numbers out of that tokenizer. That make sense? Oh, that's not the one I wanted. Process expression S. This guy should be 138, 136. Eey, what's 136 times 5? 680. So it should output 680. Oh, yeah, we'll see. This works actually. So we still needed to remove our white space. There's our 680. We were trying to, what we got is we got a number 125 space. Okay, so that's kind of maybe a little bit cleaner version of the homework assignment.
What about if he's going to take like but decide is it like digits or letter or space? I mean, when the method decided this is like the first statement.
Well, here, let me show you. Let me show you an easy way to get around this. So right now we're getting an error when it looks like this.
I mean, if I have questions, if I have like different.
Well, let's just use this as the example. So right now we have an error because we're trying to pass 125 space, that string, in integer.parseInt. Okay, so we get our number format exception. There's another method, so I'll put another, this is a Christmas gift from Home Depot. There's a method called trim. This is an instance method in the string class which removes all starting and ending white space from a string. So if I had the string and I called trim on it, it would give me that. Trims the white space. But it would not give me that. I'd still keep my space in between the two words. So it just cuts off all the extra spaces on the end. So that's a quick little method for getting white space off of a string called trim. And it's an instance method. So I'll come into here, and what do we want to do? Whenever we call integer.parseInt, we'll call it on curToken.trim. And there's our 680. So now we're able to give it as many spaces in between these guys as we want. If we want to make it super freaky, it'll still work. Because they're trimming all that white space.
If I have like float number 15.5, it's going to take like both of them.
That's not an integer.
Okay, yeah.
So integer.parseInt on 3.14 isn't going to go well.
No, I mean, check. If you check this, it's going to take all of them like as a float. Or
So if I do 13.4, number format exception. 13.4, the string 13.4 is not an integer. So calling parseInt on it is going to give you an error.
It's gonna be a double.
Actually, my question is, if he's going to take it, has taken it, it's come like 13 or like 13 as a separate 13.5 or together 13.5.
Even if I have like that, how is it going to get the token?
Yeah.
The token will be 13.5. Why? Because my tokenizer splits on plus, minus, times, divide.
Oh,
If I also said split on the period,
thank
I would get 13 in the 5.
Thank you.
All right, questions on that? Okay. So, before we talk about the homework, one more death quiz.
Huh? 2 quizzes in one night.
Well, the first one was crap.
The second one probably isn't gonna be better.
Well, I hope it is. So, take out another piece of paper. All right, so you're going to write a method called equals that takes in 2 strings as a parameter, S1 and S2. And this guy should return true if S1 and S2 contain the same characters. Exactly the same characters, case sensitive and all. The one caveat here, you cannot use the equals method of the string class. So an unacceptable solution to this is return S1 dot equals S2. Can't do that. You have to write it manually. All right. So that's the final quiz for the day. After we do that, we'll talk about your homework assignment. I'll eat my other hot dogs. I wonder how the pause works on this. Okay. So, for starters, these guys can only be equal to each other if they're the same length. Right? So, if S1 dot length is not equal to S2 dot length, return false. Right off the bat. If I'm still kicking, there, then I know I'm dealing with two strings that have the same length. So now it's a matter of going through those strings and determining if all the characters identically match each other. So for int I is equal to 0, I is less than S1 dot length or S2 dot length, doesn't matter which you choose because they're the same length. I plus plus if S dot char at I is not equal to S2 dot char at I. If I find a character where they're not equal, return false. Otherwise, return true. So, if I got through that whole for loop and never returned false in there, remember, return statement makes the method immediately end. So if I got through this entire for loop, as I went through this for loop, I checked each of these guys. I said, if S1's character at bucket I is not equal to S2's character at bucket I, if I find even one character where they don't match, return false. End the whole thing. So, first hurdle, make sure they're the same length. If they're not, return false. Then, assuming they're the same length, let's check every character. If I even find one character that doesn't match up between the two of them, return false. If I'm still alive, that means they have the same length and they have all the same characters, so I'm going to return true. So that's the equals method. Make sense? All right, questions about that one? All right, so let's talk about the homework assignment then. For starters, I think it's a 12-page paper this time.
Please don't.
Let me make sure it's viewable. Oh, I already unlocked it. That's right. Okay, so homework number 4. So, you're going to write a Java program that has at least the following two methods. I say that because you're probably going to write a whole bunch of helper methods, kind of like what we did in class today, right? You should thoroughly test your methods on several different values. The first method should be a method called base to decimal. It's going to return an integer, and it's a class method. This guy should take a string as a parameter, representing a number, and the base that that number is represented in. That's the radix. So this method should take a string representing a number and the base of that number, and it should convert that number to its decimal equivalent and return that value as an int. You may assume that the radix is a number between 1 and 36.
Oh, wait, so the radix is the base that the number is represented?
For example, I might give you something like this. Well, here, I'll do it on a PowerPoint slide. I might ask you to take the string 1011 that's currently in base 2 and give me the decimal version of it. That should give me an 11. So if this was your example input, you should get an 11. So that's base 2 decimal. So taking a string representation of a number, then an integer that says what base that number is in. So this is a base 2 number, but this could be a base 10 number, couldn't it? That's 1011 as base 10. It's 1011 as base 2. So it could be a base 3 number, a base 4 number, a base 5 number. Make sense? So, you know, a base 8 number, for example, has legal digits 0 through 7. So I couldn't say this. This would be an illegal input. I couldn't say 98 in base 8. That make sense? Can't say 98 in base 8 because 9 is not a legal digit in base 8 and 8 is not a legal digit in base 8. You don't need to check for error input. You can assume the input that comes into your methods is legit. I want your methods to function correctly. I don't want you to spend a lot of extra effort checking to make sure the inputs are accurate. Okay? So, for example, had I given you that, this is the 1's place, the 2's place, the 4's place, the 8's place. This is 8 plus 2 is 10 plus 1 is 11. That should give me the decimal number 11. That makes sense? If I gave you 1, 2, and said this was base 8, this is the 1's place, this is the 8's place, that's 8, 9, 10. So this would be the number 10 in base 8. So the decimal number 10 is equivalent to the base 8 number 12. One F in base 16. This is the 1's place, this is the 16's place. This is the 16 plus a 15. F is a 15. 0 through 9, A through F. A is a 10, B is an 11. Okay, so if you haven't done number conversion stuff before, just do a Google search on converting between bases. You'll find they're all identical. That's the point of this assignment. Whether you're converting between base 8 and something else, or base 8 to decimal is the same thing as base 12 to decimal. Is the same thing as base 4 to decimal. You do the same math. The difference is that in this is base 16, this is the 1's place, this is the 16's place. Since this is base 8, this is the 1's place, this is the 8's place. This is the 64's place. Make sense? You jump by 8s, or you jump by 16s, or you jump by 10s, or you jump by 4s. Works that way. So if this is 1F, this is the 1's place the F is in, which is a 15. This is the 16 place the 1 is in. So this should be a 31. Okay? That makes sense for what the first method needs to do. Second method is decimal to base, where you take in an integer number and the radix, and this method should take a decimal number and as an int, and the base you wish to convert that number to, and return the string version of that decimal number in that base. So what does that mean? That means if I take in an 11 as my decimal number and a base 2, it should produce 1011. If I took in a 10 as my decimal number and a base 8, it should produce 12. If I took in a 31 and a base 16, it should produce 1F. It should undo what your other one did. Does that make sense? They are inverses of each other. So one goes from a string representation of a base number in a certain base and converts it to a base 10 number as an integer. The other one goes from a base 10 number as an integer along with the base that you'd like to convert it to, and it returns a string that is a representation of that decimal number in that base. Make sense? Okay, so that's the programming assignment. Let's see about this paper. Hopefully it's a hard one. Let's see. Oh, 3 to 5 page. Discussing the role of binary, octal, decimal, and hexadecimal in computing. At the very least, cover the following topics. Why do we need so many different ways to represent data? Efficiency related to working with different number bases. And when and why might we need to use a base greater than 16? Make sense? So the programming side and the paper side are related to each other. Questions, comments, concerns, bribes? All right. I will see everybody next